Welcome back, students. So I think you're all doing wonderful. As I promised, I told you, right, we'll be starting with the NEET series. So I've kept it in the community tab and the response was very good. So most of the students have asked me to start off with the rapid revision, means rank booster questions. What I did is I've selected a lot of questions for you all which are from every part, means it covers every topic of your NCERT. And even I have selected questions which will really boost up your rank. Let's see the question. In each and every, I'll be teaching 100 plus questions in the series. I'll be reading the question, I'll be giving you the explanation for that, and I'll also be telling you how to mark the answer, right? So let us start off today with the first question. As I promised, I'll be there with you all till the NEET exam, right? All the best, students. Let's start. So in this first question, I'll be going slowly and I'll be giving you all the concepts, so keep noting it. Right, let's read this. What do they give us? They've given a compound here. They've asked us which one is a quaternary carbon atom, whether it is C1, C2, C3 or C5. So basically, when such compound is given to you, first you need to give the number to this. Now confusion starts. Where to start from? Should I start from here or should I start from here? So basically, they said they've given the clue there are 5 carbons, right? So you have to remember, important thing is the carbon, or this is R, which one is a quaternary set. First of all, we very well know primary, secondary, tertiary and quaternary. Quaternary is a carbon which is attached to, which doesn't have any hydrogen, isn't it, right? So carbon which doesn't have any hydrogen is called quaternary, correct? So here this is the carbon, quaternary carbon, so they should get the minimum number, isn't it? So let us number this. This is 1, this is 2, right? This is 3, this is 4, right? So this becomes your 5th one, and this is also 5th one. Now what is the correct answer? C2 is the correct answer, isn't it? Now C2 is a quaternary carbon atom which doesn't have any hydrogen. So this is the answer, C2. Done. So this is how you solve. I've done it in a simpler way. Let's come back and do the next question. Now let's come back and read the next question, students. What does this mean? Equal volumes of monoatomic and diatomic gases are taken at the same temperature. Okay, so they said equal volumes of monoatomic and diatomic gases are taken, and pressure, same temperature, they've taken at the same temperature and same pressure. The ratio of adiabatic exponents of the gases will be. So once again, let's read. Equal volumes of monoatomic and diatomic gases are taken at the same temperature and pressure. Okay, the ratio of adiabatic exponents. So this is your clue which they've given. So adiabatic exponents of the gases will be. So first of all, equal volumes of monoatomic and diatomic they've given. So for monoatomic gases, what is the adiabatic expression? So let us take both. Right, so first one is for monoatomic gases and next one is for diatomic gases. Okay, so for monoatomic gases, the adiabatic exponent, how do you write? We represent it by, let us take for monoatomic as gamma 1. For diatomic, let us take it as gamma 2. So what is the formula? Gamma 1 is equal to Cp by Cv. So for gamma 2 will be Cp by same thing, Cp by Cv. Okay, what did they say? They said that taking the same temperature and pressure they set. Correct? Yes. So for monoatomic gases, Cp by Cv basically, right? So the gamma value is, how much is it? It is equal to 1.67. Correct? Yes. Now for this one, for diatomic gases, the adiabatic Cp by Cv value is 1.40. Now let us take the ratio of this. Therefore, gamma 1 is to gamma 2 ratio how much? 1.67 divided by 1.40, right? Yes. So how much will it come to when I solve this? I get an answer of 1.19. This one is to 1. So the correct answer is 1.19. So just go back to the answer and mark it. Hope, students, this is clear. Now let's come back and read the third question. Gradually I'll be going into the difficulty level. So let's read this. So here what do they give us? Now this is an organic question. Let's see. Which amongst the following compounds has the highest acidic strength? So basically acidic strength. So what is this concept of acidic strength? You have to remember always, first important clue is whenever a question of acidic strength comes or highest acidic strength comes, you need to remember if there is an electron withdrawing group. Remember, if electron withdrawing group is there, acidic strength increases. Acidic strength increases. This is the first concept, right? Now suppose in the other way, if electron releasing groups are present, acidic strength decreases. Remember this. Now they asked me to write which has the highest acidic strength, isn't it? Now I have to check among all these which has more as electron withdrawing group. Correct? Yes. Now we very well know among the compounds, electron releasing groups, what are they? Electron releasing groups are always alkyl groups. Remember, alkyl groups are electron releasing groups, right? And they have what effect do they show? They always show plus psi effect, right? So whenever there is an alkyl group present in that particular compound, automatically the acidic strength decreases. So remember this concept. Let us put this as 1, let us put this as 2. So alkyl group is there means acidic strength automatically decreases. Okay, acidic strength decreases because it is electron releasing, right? Right. Now let us come back and see which one has a alkyl group. So in the first compound, is there an alkyl group? Not there. In the second compound, there is an alkyl group here, CH3. In the third compound, there is again an alkyl group. There are how many alkyl groups? 2 alkyl groups. Me means 2 methyl groups, isn't it? 2 methyl groups. In the third one, there is 1 methyl group present. Correct? Now among the, I have to write the order which has, I told you, wherever there is alkyl group, that is less acidic in nature. Wherever there is no alkyl group, that is more acidic in nature, highest acidity, right? So let us write the order now, right? So once again repeating, more of alkyl groups means less acidity, less of alkyl groups means more acidity, means electron withdrawing group should be there. Now in the first one, as I told you, there is no electron withdrawing groups, so the order would be CF3COOH, strongest among all those things. Next let us see, this has 1 and there is 1 oxygen also here, right? So you can take that electron withdrawing, it will pull the electron, because it is electronegative, it will drag the electron density towards it and hence it will become more acidic. This is 1. Next I have to compare between these two. Now this one has only 1 CH3COH. Among that, the last one is methyl group which has 2, so COH. So because of the presence of alkyl group, it is less acidic. Because of the absence of alkyl group, this is more acidic. So the first option is the correct option. Let's come back and see the next question. Let's come back and do the next question, students. I hope slowly you are learning the concepts. Let's see this. So these are basically hand-picked questions, very important questions for your NEET examination. So let's read. Here what did they give us? At 0 degrees and 1 atmosphere pressure, a gas occupies 100 cc volume. If the pressure is increased to 1.5 times, the pressure is increased, it seems, and temperature is increased by 1/3 of the absolute temperature. Pressure is increased by 1.5 times and temperature is increased by 1/3 of the absolute temperature. The final volume of the gas will be, what is the final volume? They're asking us. They've given us 4 options, right? So basically, what is the formula which is relating pressure, volume and temperature, right? So we have 2 different things, isn't it? So for a gas, they said temperature is increased by 1.5 times and temperature is increased by 1/3 of absolute temperature. Let us write the formula. So the formula which is relating all these is nothing but P1 V1 by T1 is equal to P2 V2 by T2. Correct? Now what is P1 in this? Basically P1 is, I said, 1 atmosphere pressure. So P1 is 1 atmospheres. Then now what will be the P2? They said pressure is increased by 1.5 times. So pressure will be 1.5 times. That is 1.5 atmospheres. Now what is T1 here? T1 they said it is 0 degrees centigrade. Yeah, to 0 degrees centigrade is nothing but 273 Kelvin. Correct? Now what is T2 now? T2 they said it is increased by 1/3 of absolute temperature. So what is absolute temperature? It is 273. Okay, basically I am converting that 273 plus 273 into 1/3 because it is increased 1/3 times. So this comes, when I divide, this comes to 364 Kelvin. So T2 is this. Now what is V1 here? V1 they said 100 cc volume, so V1 is 100 cc. Now V2 I need to find, because they've asked me what is the final volume of the gas. Now apply these values in the formula which is given. So basically all the data is there, only I need to find V2. Now let's start off applying. So V2 I need to find out. Let us take V2 out. V2 is equal to cross multiply this with this and this cross multiply. So I get V2 is equal to 1 into 100 divided by 273 into 364 by 1.5. This is nothing but I cross multiply. This is P1. This value is your V1 and this is 1.5 as usual, which I have taken from here. When I solve this, I get an answer. V2 is equal to 88.9 cc. So this is the formula. So 88.9, that is the option B. Option B is the correct one. Right, students? So hope this is clear. So let us come back and do the next one. So let's start off with this numerical, students. This is the thermodynamics numerical. Let's read this. So what do they give us? If the enthalpy of hydrogenation of benzene liquid is converted into C6H12, okay, right, then the enthalpy of hydrogenation, okay, the energy of while adding hydrogen is minus 205 kilojoules, and resonance energy of this is minus 152 kilojoules per mole, and the enthalpy of hydrogenation of this compound, conversion of this compound to this compound is what? I have to find that. So basically, first of all, I have to clearly know the terminology before I do this. What are they? You very well know enthalpy of hydrogenation, right? The energy, right? That is the heat evolved for hydrogenation. That is what is the concept, isn't it? Now let's see. First of all, I have to find out the enthalpy of hydrogenation. Now let us write the equation for this. So first of all, C6H6 was there, okay, the liquid. Now what did they do? They added hydrogen to this. They have used certain amount of energy to add hydrogen, okay. Why did I take 3? Because to balance it, because they have given me already C6H12, isn't it? So 6 hydrogens here, 6 hydrogens here, that's why I have taken 3 hydrogens. So this is hydrogen gas and this is the liquid. Now what did they say? The enthalpy of hydrogenation delta H HYD. This is enthalpy of hydrogenation of what? Of which one? C6H6 liquid. How much was it? It is minus 205 kilojoules, correct? Yes. Then benzene, basically this benzene is on the reactant side. So if benzene on the reactant side means I have to add resonance energy to this. They've given no, and resonance energy also they've given me. So I have to add resonance energy to this of benzene with a sign. Yes or no? Correct? Yes. So heat evolved for hydrogenation of 3 bonds means how much evolved? Because resonance, this is on the side. I have to add the resonance energy and to add 3 hydrogens. What is the heat evolved? I have to write it. So let's come back into, I'm going to add minus 205 minus of 152. How much will this come to? This will come to minus 357 kilojoule per mole. Correct? Now delta H, that is enthalpy of hydrogenation. How many are there? 3 hydrogens we have added. So minus 357 by 3, which comes to minus 119 kilojoules per mole. So the correct option here is option D. So this is clear, students. So because this is on this side, I need to add to this. I am adding that resonance energy. That is what they've given, and resonance energy of this also is given. So let's come back and do the next numerical. Hope this is clear. Read the question carefully, write the equation, write what is given, see where you have to add the given value, and then finally find out. Why did I take 3 here? Because it is, we are adding your means heat evolved for hydrogenation of 3 double bonds, isn't it? 3 double bonds I have to, because I broke those and then I added hydrogens, 3 hydrogens. Basically benzene has 1, 2, 3, isn't it? I broke those and I added. So 3 double bonds, I have taken this concept. Now let's come back and read the next question, students. Very easy question, I believe. Let's see this. What do they give us? For the purification, isolation and separation of organic compounds, the latest technique followed is, okay, so for purification, isolation and separation, what is the technique? They've given us 4 different techniques here: chromatography, steam distillation, fraction distillation and sublimation. basically when I have to speak among all these, chromatography is a modern technique. What do? Here separation of mixtures is, they separate the mixtures into components. Whatever mixtures are there, they separate into different components. Here purification of this compounds is also done, means different purification techniques are applied. In this chromatography, paper chromatography, thin layer chromatography, all these different techniques are available. But when it comes to steam distillation, what is this? Here, what is steam distillation? Basically, it is distillation of a liquid in current of steam, correct? So here, to purify the liquid, means here we are going to purify the liquids which are not very volatile, means which are immiscible with water, right? So once again, steam distillation is distillation of a liquid in current of steam, and this technique is used to purify what? They are used to purify liquids that are not very volatile and which are immiscible. Now when it comes to fractional distillation, what do? This is basically a separation technique. We are going to separate liquid mixtures into fractions. On what basis? We are going to see, based on the difference in boiling point, I am going to separate those. Here in sublimation, what is the sublimation? Basically, it is a transition of a substance directly from solid phase to gaseous phase, correct? They are going to transfer from transform, or it gets converted, solid gets converted to gaseous phase without any liquid phase. So solid directly to gaseous state, correct, right? Sublimation is endothermic, means you have endothermic phase transition also in this. Fine. So now what I'm trying to tell you, among all these techniques, hope this is clear. Here we are going to do the distillation of liquid in current of steam. Here we are going to separate it based on boiling point. Here solid is getting converted to gaseous phase without liquid. So the latest technique is chromatography, where we separate, means there will be separation of mixtures into components. Okay, so answer is latest technique is chromatographic technique. Let's do the next question. Here what did they give us? They've given us the temperature at which a gas shows maximum ideal behavior is. Okay, this is a very famous question. So the temperature at which gas shows maximum ideal behavior, and that too for considerable range of pressures. Yeah. This is Boyle's temperature. Okay, so what is Boyle's temperature? It means basically this is the temperature at which a real gas exhibits ideal behavior, right? So this is for a considerable range of pressures, right? So let's come back and do the next question, students. Let's see this question. What do they give us here? They said the temperature at which a gas shows a maximum ideal behavior is known as. Okay, so they have given us 4 options, right? So the temperature at which a gas shows a maximum ideal behavior, I need to know. First of all, before taking the answer, I have to be clear what is the meaning of all these temperatures. So first of all, let's start with the last one. What is absolute temperature? So absolute temperature is that temperature at which, it's a temperature which means it's close, or it is measured from absolute zero, correct? Absolute temperature is the temperature measured from absolute zero and which is taken in kelvins. That is absolute temperature. But here they say the temperature at which gas shows maximum ideal behavior. Okay, so this is temperature which is measured from absolute zero. Let's come back to critical temperature. So what is critical temperature? It's a temperature at which a gas is a critical stage. It's in critical stage. Means what happens here? Above this temperature, what happens? It cannot be liquefied. Okay. Again, critical temperature is a temperature above it. A gas cannot be liquefied by pressure alone. Means by pressure, using pressure, I can't liquefy the gas. Next, what is inversion temperature? So inversion temperature is something, if I take a gas, here at this temperature, gas is neither heated nor cooled, right? So gas is neither heated nor cooled, or when it is allowed to expand. Once again, inversion temperature basically is the temperature at which Joule-Thomson effect for a given gas changes its sign. So what is this here? Joule-Thomson effect means, what does it mean? Basically we are trying to say gas is neither heated nor cooled when it is allowed to expand, right, without expanding energy. So nothing of this We are not speaking anything about this in ideal behavior. Here we are speaking about the temperature at absolute zero. Here we are speaking where the gas cannot be liquefied. Here we said inversion temperature, gas can either be heated or not cooled. Correct? Now what is Boyle's temperature? Basically Boyle's temperature is a temperature at which a real gas exhibits ideal behavior. So this is the correct option. Once again, Boyle's temperature is a temperature at which a real gas exhibits ideal behavior for considerable range of pressures. It is also related with van der Waals constant. What is the formula? Basically, it is related by van der Waals. It is related to the formula that is van der Waals constant, that is TB is equal to EA by BR. This is the thing which is means the Boyle's temperature is related to this. So once again, Boyle's temperature is the temperature at which a real gas exhibits ideal behavior. Inversion temperature, in which gas can either be heated or cooled. Critical temperature is that where the gas cannot be liquefied. Absolute temperature is something which is taken as absolute zero. So the correct option for this question, the temperature at which gas shows maximum ideal behavior, is Boyle's temperature. Right? Let's come back and do the next question. Let's see this question now. So this is again a grade 11th question. Let's read this. So what do they give me here? They said enthalpy of combustion of methane, ethane and propane are enthalpy of combustion. Okay, what is enthalpy of combustion? Basically, enthalpy of combustion is denoted by the alphabet delta Hc. Okay, so how much is given? These are the values which are given respectively. Enthalpy of combustion of hexane can be predicted as, I have to find the enthalpy of combustion of hexane. Right, so what do they give me? Basically, I have they've given me enthalpy of combustion of methane, ethane and propane. Right, fine. So hexane formula is what? C6H14. I have to find out enthalpy of combustion of C6H14. Hexane is how much I need to find out. So how to do? Let us see the procedure. First of all, take the enthalpy of combustion of C2H6. See how I am solving it. Minus enthalpy of combustion of methane. How much do I get? How much is enthalpy combustion of ethane? It is minus 368.4 minus of minus 210.8. How much do I get? I get minus 157.6 kilocalories. This is done. Now, next one. The third one is propane. Now take out this from this value. Let's see. Step 2. Enthalpy of combustion of propane, C3H8 minus enthalpy of combustion of ethane. See, because I have to get for hexane, isn't it? So minus 526.2 minus of minus 368.4. How much do I get? I get minus 157.8 kilocalories. Right. Now, why did I do this? Because now the average enthalpy of combustion of hexane I can take. Because together only, hexane is C6H14. Now you see here, from C2H6 I've got this value of subtracting. After taking this I've got this. Now I can write average delta Hc for C6H14 is equal to delta Hc C3H8 plus 3 times, means after balancing, Hc of CH2. Why did I do this? Because I need the value of this. Because I need this value, so I have taken this out. So when I solve this, how much do I get? I get minus 526.2 plus 3 into minus 157.7. So when I do this, multiply, add and everything, right? So I get an answer. Just solve the students. 56, yeah. So when I solve this particular question, right? So after solving this everything, I got a correct answer of minus 993.3 kilocalories per mole. So do the calculation, students. So I've done it, and finally the answer which I got is option C. Let's come back and do the next question. So let's come back and read the next question, students. A bit lengthier question, but let us understand the concept. So what do they give us? It is more convenient to or it is more convenient to obtain the molecular weight of an unknown solute, okay, by measuring the freezing point depression and by measuring the boiling point elevation. Because, right, so let us see the option. Why are we taking that to calculate? Why are we taking freezing point, or why are we taking the boiling point elevation? By? Because let's see. First of all, first option is freezing point depression is a colligative property, whereas boiling point elevation is not. Wrong, isn't it? So colligative properties we have 4. One is relative lowering of vapor pressure, then we have the elevation boiling point, then depression freezing point, and osmotic pressure. So the first one is wrong. Next option, freezing point depression are larger than boiling point elevations for the same solution. Yes, this is the correct answer, isn't it? Right? So, right. So let's see whether third and fourth are also related. Freezing point depressions are smaller than boiling point elevation. Wrong, isn't it? Here we said it is larger. Third option is wrong. Freezing point depression depends more on the amount of the solute than boiling point elevation. Right? So basically the correct answer, the relevant answer related to a question is freezing point depression are larger than boiling point elevations for the same solution. That's what we have marked this. Let's come back and see the next question, solutions chapter of grade 12 wisdom. Let's see the next question of the chapter. Let's see which question we're going to get. This question, okay, this is basically an electrochemistry chapter question, right? So solutions we have done. Now let us see electrochemistry question. What do they give us? In a galvanic cell, the electrons flow from, okay, the simplest question. So they have given here one option, galvanic cell. So basically in galvanic cell, from where do the electrons flow? Remember, so in a galvanic cell, always electrons flow from anode to cathode. Okay. In galvanic cell, electrons flow from anode to cathode through external circuit. This is important. To external circuit. Okay. Right, students? Right. So they asked us electrons flow from where? Let's see the options. Anode to cathode through external circuit. Yeah. Anode to cathode through solution, this is wrong. Cathode to anode through external circuit, that is wrong. Cathode to anode through solution, wrong. Basically here electrons flow from anode to cathode. What is this? Anode is a negative pole. What will happen at this anode? Always oxidation. That is loss of electrons. That's why electrons flow from anode. Loss. Let us write that. Loss of electrons. From where do they go? They go to cathode. What is the charge in that? Cathode is a positive pole. What will happen here? Reduction will happen. So what is reduction? Reduction is nothing but gain of electrons. So always remember, in galvanic cell, electrons flow from anode to cathode. So the correct option is anode to cathode through the external circuit. Hope this is clear, students. Right? Let's come back and do the next question. Hope I have written the concept clearly. Understand the concept, so it's easy for us to do it. Now, after the electrochemistry question, let's read the next question and see. So here, they've given one organic reaction. Let's see this. They said ethylene reacts with Bayer's reagent. Okay, to give what? So ethylene reacts with Bayer's reagent. They said. So basically, preparation of preparation of alcohols from alkenes. Hence, this is the basic concept actually. Right? So let's write the reaction first and see what product we get. What actually is Bayer's reagent? Basically in organic chemistry you have to remember different types of reagents, students. So as soon as Bayer's reagent is or a Bayer's reagent is given to you, you have to be clear what actually is this. Bayer's reagent is nothing but alkaline solution of potassium or alkaline solution of cold potassium permanganate. Let us write that. Bayer's reagent, not solution. Bayer's reagent is nothing but alkaline solution of cold potassium permanganate. What is this importance of potassium permanganate? It is a very powerful oxidant, correct? It is powerful oxidant. And let me change my sketch pen, I believe. Let me take a different sketch pen, students. Right. So here, powerful oxidant of written. Let us say the reaction now. So basically, ethylene CH2 double bond CH2. Done. It's reacting with what? Alkaline solution of KMnO4. So KMnO4 plus water. Alkaline solution is there, isn't it? So what do we get here? Understand carefully. So basically here KMnO4 is an oxidant, means it's going to add oxygen to this. It's going to break this bond and add oxygen, and what do you get? CH2, OH and OH. What is the name of this compound? This is nothing but glycol. Now what happened to this? KMnO4 gets converted to KMnO2 plus KOH. So if I have to balance this, 3, okay, so this is 2, this becomes 3, this becomes 2, water, this becomes 4. So this also becomes 3, this becomes 2, this becomes 2. Right. So this is the reaction. So what did we get? When ethylene reacts with Bayer's reagent, that is cold solution or alkaline solution of cold KMnO4, we are going to get a product that is glycol. Right? What is this glycol? This is ethylene glycol. So the correct option is ethylene glycol. Right? So here, so it took 2 carbons, isn't it? CH2, CH2, 2 carbons are here. So it is ethylene glycol as a product. Hope this is clear, students. Let's come back and do the next question. Now let's come back again, do one more question. Let's see this. I think this is a grade 11 question. Let's see. Which of the following is never true for cathode rays? Right. So basically, whenever I speak about cathode rays, what are the characteristics of cathode rays? They said which is never true. Okay, let's see. So when I have to speak about cathode rays, the important thing or the important concept I have to remember is cathode ray has or it contains fast moving beam of electrons. Fast moving beam of electrons. That's the first one in the discharge tube. Next, they have high kinetic energy, right? And next important thing, charge in mass. Basically cathode rays, whatever charge or the electrons are fast moving thing, they have charge and they have also mass. Okay, they have fast moving electrons which has charge and mass. Done. Now important, they've asked me which is never true. Let's see. They possess kinetic energy. They possess kinetic energy. Correct. They're electromagnetic waves. This is the mistake. Why? Because let us take the option B. What did we say? We said cathode rays are fast moving or they contain beam of electrons. Correct? In the focused in the cathode ray tube. So when I say electrons, like all matter, electrons can be regarded as a wave, but not as electromagnetic wave. Why? Here I can say electrons can be regarded as waves, but not electromagnetic waves. Electromagnetic waves. Why? EM waves or electromagnetic waves, what do they contain? Basically, electromagnetic waves are made up of only photons, isn't it? Electromagnetic waves or EM waves are made up of only photons. But here, cathode rays are made up of electrons. That's why this option B is not true for cathode rays. So remember, cathode rays contain electrons. Electromagnetic waves contain, or the EM waves contains photons. Hence, the second statement is not true for cathode rays. Now let's come back and do the next question, students. Here, this is again a grade 12th coordination chemistry question. Let's read this and let's see what we're supposed to do. Here they said coordination number of calcium is 6n. So directly they have given us an answer that coordination number of calcium is 6. I have to draw the structures and find out in which compound is coordination number 6. So basically, what is coordination number? Coordination number is number of nearest surrounding atoms. Means the number of surrounding atoms around the central metal atom. So in this case, calcium is a central metal atom. Right? Let's see. So let us draw the structure for all. So basically, this is calcium EDTA. What is EDTA? EDTA is nothing but ethylene diamine tetraacetate. Correct? Ethylene diamine tetraacetate. Let us write. So first of all, the central metal atom is calcium. So let us see calcium. I am making it center. Now here ethylene diamine tetraacetate. So nitrogen here, nitrogen here. This is linked to calcium. This is linked to calcium. Tetraacetate we said ethylene diamine tetraacetate. So CH2 COO minus. One more is CH2 COO minus. So this is also coordinated to this. This is also coordinated to this. Next, CH2 COO minus. This is coordinated to this. One more, CH2 COO minus. This is also coordinated to this. 1, 2, 3, 4, 5, 6 are already over. Ethylene diamine, ethylene we said. So this is the compound. So the first one is this. So here how many are surrounding the central metal atom? 1, 2, 3, 4. Okay, let's count 1, 2, 3, 4, 5, 6. Correct? Yes. So 1, 2, 3, 4, 5, 6. Here the coordination number is 6. Done. Let's see the next one. So first option I have already got, ethylene diamine tetraacetate. So coordination number 6. Let me see whether this is anything is there or not. I mean, any other questions related. Here, what is this? Calcium oxalate, isn't it? This is calcium oxalate. So what is calcium oxalate formula? Means structure. Basically, calcium oxalate, calcium Ca plus 2. Oxalate is C. 4 oxygens O. Dots, dotted. This is calcium oxalate. Suppose if I draw the same thing here with this. Here how many are surrounding? Here 4. Here only to this calcium. This is linked and this is also linked to this only. So coordination number is not 6. Suppose if I have to draw for this, this becomes 2 like this for this. Correct? First I have written for this calcium oxalate, then I have drawn for this, taking the charges -2. Now let's take this calcium sulfate 4H2O. How do we write this? Basically, calcium is in the center. So 1 hydrogen here, 1 H, OH, this is 1. 1 more water molecule, O, H and H. 4 water molecules, isn't it? So O, H, fourth one, O, H and H. This whole thing again, what is the calcium sulfate? 4 water molecules are over, so calcium sulfate, isn't it? So this and this. Again here you have to draw one sulfate, SO4, dotted, here also dotted, right? So this, how are these two linked? Basically these two means through the hydrogen bonding. This is an hydrogen bonding, this is a hydrogen bonding. Correct? So this is +2, this is -2. So here this calcium is attached to the sulfate by hydrogen bonding. Now how many other? 1, 2, 3, 4. Correct? So here also 4. Here almost I have to take this. This is 1 attached and this is the second one. Here the coordination number is 6. Here the coordination number is 4. Here the coordination number is 6. So the correct option is this is calcium EDTA -2. Here we have 1, 2, 3, 4, 5, 6 surrounding atoms, nearest neighboring atoms. So the coordination number is 6 in this. Let's come back and see the next question. So after that coordination chemistry equation, let's read this question, students. So what did they give us? They said the rate of SN2 reaction is maximum when. So they said the rate of SN2 reaction is maximum when the solvent is. So they have given different solvents. One is methanol, one is water, one is DMSO, and one is benzene. Okay. So basically, whenever it is SN2 or SN1 reactions, you have to remember important thing. What is that? For SN1 or SN2. Let us divide like this and remember now only. So right, so basically SN1 is what? Unimolecular reaction. This is bimolecular. Here what in SN1 what happens? Here carbocation stability, biggest barrier is carbocation stability. Now here steric hindrance, that's the most important. And here what is the option? Here tertiary greater than secondary, very much greater than primary. Here primary greater than secondary, very much greater than tertiary. Now here in SN1 very weak, means the nucleophile whatever they generally nucleophile is very weak. Correct? Let us write that. Weak nucleophile. In SN2 it is strong nucleophile. Right. Here in SN1 what is the solvent we require? Always remember in SN1 we require polar protic solvents. Let us write this is 1, 2, this is 3. Polar protic solvents. Let us name one polar protic solvent, basically alcohols. Alcohol. For SN2 we always require, let us name this is 1, 2, 3. For SN2 we will always require polar aprotic solvents. Aprotic solvents. What are they? Examples are DMSO. Examples are acetone. Now here there is retention and inversion. If I have to take the last one, you observe retention and inversion. When I see SN2, inversion is observed, no retention. So these are the points which you have to remember. Okay. So here they said among now SN2 they said SN2 what is a solvent? SN2 the solvent is DMSO. So here the option given is DMSO solvent. So a DMSO solvent, what is the full form of DMSO? It is dimethyl sulfoxide. Let us write here dimethyl sulfoxide. Right? So the correct option is C option. So remember this along with this question, it will be complete analysis of that. Now let's come back and do the next question. Now after the haloalkanes, haloarenes chapter in the previous question, let's see this. Here what did they give us? They said when acyl chloride is heated with sodium salt of carboxylic acid, the product formed is. First let us write the reaction, then we'll understand. Acyl chloride. What is acyl chloride? CH3COCl. This is the acyl group. Now what did they say? It is heated with sodium salt of carboxylic acid. So basically carboxylic acid, that is your acetic acid. Now acetic acid, what do they do? They have introduced this sodium, NaOH. If I take this, Na replaced and water comes out. So what is this? Sodium salt of carboxylic acid is this. Sodium salt of carboxylic acid. And they said these two are heated. So what it gets? NaCl is out, minus NaCl. Join these two, we get CH3 is here. Now CO is here. Here also CH3CO, CH3CO. Both are linked with oxygen plus NaCl. So what is this? This is nothing but acetic anhydride or acid anhydride. This is called acid anhydride. Right? So what did they give us? When acyl chloride is heated with sodium salt of carboxylic acid, the product form is, what is the answer? It is called acid, or it is an anhydride which is formed. Simple, students. Right. Let's come back and do the next question. Now let's come back and do the next question, students. Now, what does this question say? Let's read. So again, I think this is a surface chemistry question of grade 12. What do they give us? Alloy is an example of, okay, so alloy, basically alloy, they said they've given different options, whether it is a gel, whether it is a solidified emulsion, whether it is a solid solution, or whether it is a sol. So first of all, I should first, before putting a tick on the correct option, I have to know what actually are all these. What is a gel? Basically gel is a solid jelly, like soft, means it is a cross-link system, isn't it? What is a gel? It is a solid jelly-like soft cross-link system. Okay, cross-link system. This is done. So when I have to speak about the solidified emulsion, what is solidified emulsion? Let us write first. So emulsion basically it is, basically this emulsion means whenever you see emulsion, it is a combination of two immiscible liquids. Emulsions are combinations of immiscible liquids. How many? Two. Here one liquid is dispersed in the other liquid. So mixture of two immiscible liquids. What is now solid solution? Basically, solid solution is nothing but a solid mixed in lattice, means a solid mixture which is present in lattice of a solvent. What is this? Let us write. It is a solid mixture present in lattice of solvent. Okay, done. Now, what is sol? Sol, basically solid in a continuous liquid medium. Sol means solid in liquid, that is solid in a continuous liquid medium. Done. What are the examples of this? Basically examples are blood, examples are paint, example are cell fluids, like this. Now what they ask us, they said alloy is an example of, what is an alloy? Basically alloy is a mixture of two or more elements, isn't it, which has metallic property. It means it is a combination of two or more metals. What are the different examples? An example is brass is an alloy of copper and zinc. Steel is an alloy of iron and carbon. Like that, it is a combination of two or more metals. Correct? So here they asked what is the correct option of that. Now basically I know the definition. Alloy is a mixture of the example of I just told you it's a combination of two or more metals. But here what did we study, or what is the concept? I said it is a mixture of two or more solids or two or more metals. So what is solid solution? Solid mixed in a lattice of solvent. So solid mixture. So this is the answer, isn't it? So solid solution is a correct option for alloy. Right? Sol I should not give because this is solid in liquid. Emulsion is again liquid in liquid. Gel again is a jelly like thing. So alloy is a solid solution with a mixture of two or more metals. After a surface chemistry question where we have spoken about gel, solidified emulsions, solid solution and your sol, let us come back and do the next question. So here which chapter is this? This is basically from solution chapter. Okay. So they said the mole fraction of a solute in 1 molar aqueous solution is. Right. So we have to find the mole fraction. So basically mole fraction is denoted by which? This one, mole fraction is denoted by X, isn't it? I have to find for solute. So mole fraction of solute I need to find. Right. So what is the formula for finding a mole fraction? The formula is N by N. What is this N basically? Yeah, N, the formula of a capital N is nothing but small w by, capital W by, what is this? It's nothing but number of moles of the solvent. So capital N, we take it as number of moles of the solvent, that is that it is nothing but the ratio of weight by molecular weight. So here what is the solvent? This is 1 molar aqueous solution. What is 1 molar aqueous solution? 1 molar aqueous solution means implies 1 mole of solute in 1 kg of water. 1 mole of solute in 1 kg of water. Right? Let's try this. N of water is equal to 1000 by 18, which is equal to 55.55. Hope this is clear, students. Let's come back and see. Let's say the mole fraction of a solute in 1 molar aqueous solution of this one. So basically the mole fraction formula of means to find out X of solute, this is the formula. Correct? Now it is capital N, it is nothing but number of moles of the solvent is weight by molecular weight. So when they said 1 molar aqueous solution means 1 mole of solute in 1 kg of water. 1 kg, so 1000 grams. Now substitute. x of solute is equal to 1 by 1 plus 55.5, which is equal to 0.018. So the correct option is 0.018 is the correct option. So don't get confused, students. 1 molar aqueous solution is nothing but 1 mole of solute in 1 kg of water. Let's come back into the next numerical. So let's see the next question. So what did they give us here? Last question we have done a numerical based on the solution chapter, that was concept of mole fraction. Now here what did they give us? They said which of the following combinations will produce a hydrogen gas. So they have given different combinations of metals. Now I have to see which one produces hydrogen gas. Let us write one after the other. What is the first one? They said zinc metal reacts with sodium hydroxide aqueous. So zinc plus sodium hydroxide. Right. So what do we get? We get sodium zincate, Na2ZnO2 plus hydrogen gas if I take 2 moles of this. Next, they said gold or Au metal and sodium cyanide aqueous in the presence of air, that is oxygen. Correct. Let us write this. Au plus NaCN in the presence of oxygen. Aqueous they said, so I have to write water. So this combines with gold, forming a coordinate covalent complex, that is the complex formed as NaCN and take it twice, plus sodium hydroxide, NaOH. Let me balance this. This is 2, this is 4, it becomes 8, 4, this is 2, this is 4. This is also 4. So there is no hydrogen gas in this. When I see the third reaction, they said copper metal reacts with concentrated nitric acid. Copper plus HNO3 concentrated. What do we get? Metal plus acid. Yes, means important thing is nitric acid, when it reacts you get there is evolution of nitrogen dioxide gas. So copper nitrate first forms, then nitrogen dioxide is evolved out with water. So let us balance 2, this is 2, this is 4. Okay, so there is no hydrogen gas evolved. Now in the fourth case, they said iodine reacts with concentrated nitric acid. So this is concentrated nitric acid. Let us do concentrated nitric acid. Here there is a formation of passive layer, means you get first the formation of Fe2O3 on the surface of Fe, and nitrogen gas also is evolved. So you get a passive layer of Fe2O3 on the surface of Fe. The coating forms. So Fe2O3 on surface of Fe, and nitrogen gas is evolved out. Right? Yeah, that's it. So here when I see all the options, which is the reaction which will produce hydrogen gas, right? So basically the reaction, or when I see this one, the first reaction, isn't it? In the first reaction only I get the evolution of hydrogen gas. So the correct option is A. Let us take that. Please note the reaction, students. Let's come back and do the next, solve the next question. I'm going very slowly so that your concept is clear for you all. Now let's come back and start with the next question, students. Now the next question, we have a numerical to be solved. Let's see this. What did they give us? They said dissolving 120 grams of a compound of molecular weight 60 in 1000 grams of water gave a solution of density 1.12 gram per milliliter. The molarity of the solution. So directly they have asked you means to find the molarity. So basically let's note what data we have. So what is the mass of compound given to us? Mass of compound 120 grams. Correct? So I can directly find moles now. No? Moles is weight by molecular weight. So 120 grams by molecular weight, they've already given in the sum here 60. That is gram per mole. So how many number of moles? 2. Next, mass of solution. because I have to calculate molarity, isn't it? So mass of solution is equal to, solution is nothing but 1000 grams of water, correct? In that 120 grams we have dissolved already. Solution means solute plus solvent. So 1000 plus 120 comes to 1120 grams. Now volume of the solution is equal to, density is equal to mass by volume. Now volume is equal to mass by density, correct? How much is mass? Mass is nothing but 1120. How much is the density? 1.12 gram per milliliter. How much do I get? 1000 ml. Now calculate molarity. Directly I have all the data. Molarity is equal to 2 by 1000 into 1000 ml. This is ml, this is moles. So this and this gets cancelled. So how much? 2 molar. What is M means? M is nothing but number of moles by number of moles per liter, correct? So the answer is 2. So 2m is the correct answer, correct option. So I've marked C option, C is the right option. Let's come back and do the next, or solve the next question. So welcome back, students. Let us come back and do the next question. Till now I have done 3 sets of questions, right? So when we come to this question, let's read this and then gradually solve. Hope you would have seen all the earlier videos, all the 4 videos. So basically, students, just important thing, if you are all not watching the videos, it is meaningless for me to upload. So you have to be very fast because days are very less for us, isn't it? Yes. So all the best for your NEET examination. Let's start off. So here in this particular question, they've given us an acid solution of 0.05 molar has a pH of 5. Okay, the degree of ionization of acid is what? Basically we have to find out, or let us see what is given to us in the exam. First let us note it and just see. Now pH is given, how much is given? 5. Okay, I need to find one more thing, an acid solution of 0.05, right? 0.005. the concentration part given to us is, concentration is 0.005 molar. And what should I find out? I have to find out alpha, that is your degree of ionization. Alpha is degree of ionization, isn't it? Right. So basically when pH is given to us, let us write the formula. This is the easiest way to do. Basically acid, that is your H plus concentration. What is H plus concentration? It is equal to 10 raised to the power of negative pH. That is what we studied, isn't it? The negative pH, or the base 10, the negative logarithm, that is equal to your acid concentration. How much is pH given to us? pH given to us, now take as 10 raised to the power of minus 5. This is the thing, correct? Yes. So now what is alpha formula, or degree of ionization formula? Degree of ionization is the concentration of the acid by given concentration. How much is the concentration of acid? 10 raised to the power of minus 5. What is the concentration now? Given as 0.005. When I cancel this, I get an answer of 0.2 in 10 raised to the power of minus 2. So this is the answer. Simplest way, isn't it? So remember, whenever this is given to you, concentration is given to you and the pH also is given to you, the easiest procedure is this. So the answer is 0.2 in 10 raised to the power of minus 2. So let me take the correct answer. Let us come back and do the next question. Now let's come back and read this question, students. Let's see what are they asked. They've given this is an organic based question. Let's see, which of the following compound does not have any geometrical isomerism? Okay, so first important thing, whenever a geometrical isomerism question is given to you, what should you remember? So geometrical isomerism, basically there are cis and trans. And next important thing is, if a particular compound has to show geometrical isomerism, it should have the group should be on different carbon atoms, because when you rotate it, cis and trans isomerism. Okay, so when you rotate, there should be movement, or there should be change of that particular position of that particular atom, right? In this particular question, they said which does not have geometrical isomerism. I said for geometrical isomerism, the particular atom should be present on different carbons. Here it is different carbons, so this will show. Now here again it is on different carbons, so this will also show. Here also the chlorine is on different carbon atoms, this also will show. Now in the last case, here chlorine is present in the same carbon. Just see now, even if you rotate also, there is no change in the structure, or there is no isomer formed from the structure. So option D, right? The option D is a correct answer, which does not have any geometrical isomerism. Why? Since the atoms or similar atoms are present on same carbon atom. This is what you have to remember, right, students? Right, so this is the easiest way. So the option D is this one. Option D is this is the compound which does not have or which will not show any geometrical isomerism. Right, now let's come back and do one more question. Let me move my book clearly. I think this is clear enough for you all. Just see, let me adjust my lens. Yeah. So now let us read the question. What it was: calculate the concentration of a solution obtained by mixing 300 grams of 25% weight solution ammonium chloride and 150 grams. This is off here. Okay, I have to calculate what? I have to calculate the concentration of the solution. Okay, so and obtained. So when by mixing 300 grams of 25% by weight solution ammonium chloride and 150 grams of 40% by weight solution of ammonium chloride. So they are given two things. One, they have given weight of solution 1 and they have given weight of solution 2. Right, what should I find out? I have to find out concentration of the solution. Right, they've given me 4 options. Let us start off. So when such question is given to you, basically let's make it easier and solve it. First, what did they give us? Weight of solution 1 and 2. First of all, I have to find the weight of solution 1 and 2. I'll tell you why. Weight of solution 1 and weight of solution 2. How much? What is weight of solution 1? It is 300 grams. What is weight of solution 2? 150 grams. So total of 450 grams is the weight. Now let's take now using that individual weights, let us calculate the weight of solution 1 and solution 2. So now let us write weight of solution or weight of ammonium chloride in solution 1. Second one, weight of ammonium chloride in solution 2. Right, so in the first one, how much is given? It is said 300 grams of 25%. That means 300 into 25 by 100. In the second case, how much they say? 150 of 40%. 150 of 40 by 100. So when I solve this, how much do I get? I get, okay, this comes to 75 grams. When I take this, okay, this comes to 60 grams. Now, right, now this is weight of the solution. Individually we have calculated according to the percentage. Now total weight of ammonium chloride, because this is solution part, this is ammonium chloride, so let us write total. Therefore total weight of ammonium chloride, how much do we get? 75 grams plus 60 grams. How much this is coming to? 135 grams. Now percentage by weight I have to calculate now, because they have given the answer is the percentage by weight. So what will I do now? Therefore percentage by weight of mixed solution. Percentage by weight of mixed solution. How much did I get? Like today I got 135 grams, isn't it? So now 135 by the total solution, that is 135 by 450 into 100. Percentage by weight. When I cancel this, I get 30% by weight. So this is a correct option. Actually, what did we do? We have taken individually. We have taken weight of the solution together. Then I have taken individually ammonium chloride, because they have given 300 grams per 25% of 25%, then 150 grams of 40%. I have calculated individually both of them. After that, what did you do? I have taken the total weight of ammonium chloride, done, but I have to find out percentage by weight of mixed solution, because ammonium chloride in this mixed solution I have to find out. They've given here, calculate the concentration of the solution obtained by mixing. So for the mixed solution, whatever weight I have got here, I have taken the total weight and calculated it. Right, let me come back and do the next question. Now this is again grade 11th, grade 12th also you have Haber's process, grade 11th also you have. Let's see, what do they give us? In the manufacture of ammonia by Haber's process, that is they've given nitrogen and hydrogen here, Haber's process reaction, that is basically Haber's process, we prepare ammonia, isn't it? Right, so in Haber's process, what did they say? They said nitrogen combines with hydrogen. They've given a balanced reaction, and we very well know in Haber's process it is a reversible reaction, and the product which we are going to prepare is ammonia, right? And they've given 92.3 kilojoules of energy was released. Done. Which of the following conditions is unfavorable? Now this is important. Unfavorable. Basically, whenever we speak about Haber's process, what thing should you remember? Remember these points. For Haber's process, the reaction is reversible. That is the first important thing. And conditions, what do? They are deduced using Le-Chatelier's principle. I think this Le-Chatelier's principle, hope the concept is clear. So we are going to deduce, means the conditions are dependent, or basically according to Le-Chatelier's principle only, we deduce the conditions and speak, or what happens to get the maximum yield, low temperature or high pressure, like that. Basically in Haber's process, the temperature which we require is 450 degrees centigrade. How much would be the pressure? The pressure which we require is 200 atmospheres. 200 atmospheres, right? Now, so according to Le-Chatelier's principle, if I have to get more of the product, the temperature should be low. Most important thing, remember this. What? According to Le-Chatelier's principle, to obtain more product, what is important? Low temperature is important. So because of this, what it proceeds towards the forward direction. Done? Yes. So I have to remember these conditions and think about the option. Now they said which of the low temperature is important as well. With this low temperature only, the means the reaction proceeds forward direction. Otherwise it goes back, reverse direction. Now let's see which of the following condition is unfavorable. Now increasing the temperature is one, this one, increasing the pressure, reducing the temperature, removing ammonia as it is formed. So now see here, I said low temperature is important, but what is the first option? Increasing the temperature. If you increase the temperature, what happens? I said the product, means it goes in the reverse order. That's why the unfavorable condition in Haber's process is option A. So if temperature is increased, as I told you, the yield of ammonia will become less. That done. So let's come back and see one more question. Let me move my book further. Yes, let's see this. So in this question, what is given? Let's read. Molecular weight of an organic acid is given by equivalent weight into basicity. Okay, equivalent weight by basicity. Done. Basicity by equivalent weight, and equivalent weight into valency. So basically here they've given molecular weight of organic acid. Correct? This is where is important, because it varies for the base, it varies for the metal, everything, isn't it? Right. So molecular weight of organic acid, simple, direct, it is a direct formula. Remember, molar mass or molecular weight, molar mass of an acid is equal to equivalent weight into basicity. This is a direct formula which you can use it. So direct, as I told you, I have given the answer. Let us come back and mark the first option directly. There is no twist in the question. So molar mass of an acid, a direct question. So I have marked that and I have used this. Right, students? Right. Now let's come back and see next question. Let me turn the page I have. Right. When I turn the page, I have one question here. It's the easiest question again, I have to tell you. What do they give me? What is the structural formula of fumaric acid? Okay. They have given structural formula of this one, fumaric acid. They have given 4 options. So basically this is also a direct question. Fumaric acid, the form or the structure or the formula of fumaric acid is this. Both the hydrogens on opposite side and COOH in opposite sides. Right? They are trans isomers, means it's a trans product basically. So fumaric acid is HH, COOH, COH, means trans. Why did I say? Because they are present in the 2 opposite sides. So the structural formula of fumaric acid is T. Right, students? Done. Let's come back and do one more next question. So here, what did they give me? The bond angle of COC, okay, the bond angle in COC, they have given one structure, that is of methoxymethane. So what is the bond angle of this? They said. So basically, whenever you see the bond angle, or this is what methoxymethane and dimethyl ether, we very well know, according to, we calculate this, means we have studied this bond angle concept in which one? In Vesper theory. According to Vesper theory, the bond angle of methoxymethane should be, because this is tetrahedral in shape, it should be 109.5, right? So here in tetrahedral structure, what will happen? 4 electron pair will be distributed in a tetrahedral manner. 4 electron pairs will be distributed. As soon as you see this, directly you will see the structure and you will mark it as 109, right? Because 4 electron pairs are distributed, and why do they distribute? To reduce that electron, means to minimize pair repulsion in between the molecules, to reduce the intermolecular pair, or in between, to reduce the repulsion between the carbon atoms. They align themselves in this 100, means giving a tetrahedral structure 109.5. But according to Vesper, it is 109. But remember, here this is an exceptional case. Here, according to electron diffraction studies, according to electron diffraction studies, bond angle was observed to be very close to 112. As of now, was observed to be 112, means basically there's no 112, it's almost 111.7. So remember students, methoxymethane specific case according to electron diffraction. According to Vesper, it would be, as I told you, tetrahedral arrangement. Tetrahedral 109, but this is wrong. Here 111.7 is the correct answer. So according to electron diffraction studies, so 109 is for tetrahedral, 180 is for linear, isn't it? Like that. So here methoxymethane, the correct answer is 111.7. So don't get confused, students. Right. So now let's come back and do the next question. Let me turn my page. Okay. Yeah, I have written the questions. Right. So let's read this question. What did they give me? In a closed vessel, or the closed flask of 5 liters, 1 gram of hydrogen is heated. Okay, there is a closed flask itself, so 5 liters capacity. 1 gram of hydrogen is heated from 300 to 600 Kelvin. Which statement is not correct? Okay, they've given pressure of the gas increases, rate of the collision increases, number of moles of gas increases, the energy of gaseous molecules increases. So what option is not correct, they said. Right. So the pressure along with number of moles of the gas, it remains the same. Why? Because it is a closed flask, isn't it? In a closed flask, remember, the pressure of and along with the number of moles, there is nothing, it is not getting isolated, means there is no distribution, it's closed inside that container only. So that container is how much is capacity? 5 liter. How much is there? 1 gram of hydrogen. It is heated from 300 to Kelvin. Everything is happening inside that only. So what option? We said the number of moles of the gas increases, the rate of collision increases, pressure of the gas increases, the energy of the gas molecules increases. See here, pressure of the gas, pressure is inside the same. The rate of collision increases, correct. But does number of mole of gas increases? No, isn't it? Because it is present inside the closed container. So this is the correct option. Number of moles remains the same. Right. Let's come back and see the next question. Right. So here, what do they give me? If two compounds have the same empirical formula but different molecular formula, they must have what? Okay, two compounds have the same empirical formula but different molecular formula. They have given option: different percentage composition, different molecular weight, same viscosity, same vapor density. So if compounds have same empirical formula but different molecular formula, so if molecular formula is different, what will happen? Molecular weight also will be different, isn't it? Yes, right students? Once again, if molecular formula is different, the number of atoms, means carbon may increase, hydrogen may increase, oxygen may be there. So if molecular formula is different, then molecular weight also will be different. Option B is the correct answer. So hope this is clear, students. Right, let me come back and do some more questions. So welcome back to the next session. I think you've followed the last 5 videos, students. Let's come back and see what are we going to solve. Here in this particular question, this is an organic based question. Let's read this. Which of the following compounds containing carbonyl group will have colored crystalline or will give colored crystalline compound. So remember, which of the following compounds containing carbonyl group? So here they've given one compound. What is this compound? This basically this is 2,4-DNP, isn't it? This is hydrazine at second position and the first position and the fourth position. 1, 2, 3, 4 means if you start like this, okay, this 2,4-DNP second position, yeah, second and the fourth position you have nitro group. So basically this is 2,4-DNP, 2,4-dinitrophenylhydrazine. Now they said this compound is going to give, means among all these carbonyl compounds, which compound will react with this 2,4-DNP and give a colored crystalline compound. So remember, first important hint in this. What is a hint? Only aldehydes and ketones will react with 2,4-DNP. Correct? No? Yes, you have to remember this. So only aldehyde group and ketonic group will react with 2,4-DNP. What do they give after combining or after reacting? They are going to produce characteristic red or orange colored solution. Red or orange colored solution. Right? So this you have to remember. So aldehydes and ketones we said. Now let's see which one is aldehyde or ketone here. So basically here this is acyl group. No. This is which one? It is a ketonic group. Okay. Ketonic group I can consider. Here this is an ester. Not. Here it is an amine. Means CH3CO NH2. Correct? So an amine group is present in that. And important thing we have to remember is, I said only aldehydes and ketones are going to combine with this. Correct? And so we can rule out that compound also which has an amine group. Yeah. So basically, what do we call this? What is the name of this compound? CH3CO NH2. This is acetamide, isn't it? So this is acetamide. This is an ester. This is an acyl group. So which is the correct option? The correct option is B. Correct, students? Yes. So hope this is clear. Let's come back and do one more. Next question. Let me take this question. Hope this is clear. The most organized. Okay, now we have come to solid state chapter, right? So we have done earlier organic chemistry. Now come to solid state chapter. Let's read. The most organized crystal system is. What is the most organized crystal system? They are asking. They've given orthorhombic, cubic, monoclinic and hexagonal. Basically, Bravais lattices, you need to remember the parameters and go, students. Otherwise, such questions you can't answer. Basically, if I have to see, let me write the parameters for all. When I have to see the orthorhombic structure, okay, orthorhombic. In orthorhombic, what is the criteria? A is not equal to B is not equal to C. Here alpha is equal to beta is equal to gamma is equal to 90 degrees. So is it an organized system? No, isn't it? Because all are not equal. All edge lengths are not equal. Now when I have to go to the next one, cubic. Here all the edge lengths are equal. The angle between them also is equal to 90 degrees. Perfect, isn't it? It is perfect organized. Let us write for monoclinic. So when I take monoclinic Bravais lattices, here A is not equal to B, which is not equal to C. Again, it is not organized. Alpha is equal to gamma, which is 90 degrees. Now beta is again 120 degree. Is it organized? Not organized. When I take to the next one, last one, hexagonal structure. So in hexagonal structure, if I have to take what is this one? A is equal to B, but B is not equal to C. Alpha is equal to beta, which is 90 degrees, but gamma is 120 degrees. So this is also not organized. They are not equal. So the only system which is, or the most organized crystal system is cubic according to the parameters. Both are equal, isn't it? Yes. So take this question, students. Now, I told you, please study the Bravais lattice parameters for all the 7 crystal systems which combine together to form 14 Bravais lattices. Now let's come back into one more question. Let me turn the page. Right. Now, what did they give me? Again, an organic equation. Propene on reaction with hypochlorous acid gives. So basically, propene on reaction. So this is basically whenever you take alkenes, we'll be talking about Markovnikov's and anti-Markovnikov's addition, isn't it? The concept of this. So propene on reaction with hypochlorous acid. So basically, let us write reaction. Propene. Propene is 3 carbon atom. So propene CH2. CH3H. This is propene, correct? Yes, 3 carbon. Now hypochlorous acid is what? HOCl. Done? So when alkene is added, there is a cleavage of the bond. There is also a cleavage of the bond, right? So minus, okay, let us take this OH. This is a minus and this is plus. So the negative addendum, okay, I should not take this as plus. Okay, let me be careful. Let's see this. According to Markovnikov addition. Now, let me see this. Now, this is Markovnikov addition. It goes according to Markovnikov addition or Markovnikov rule. What is Markovnikov rule? Hope you would have, it's clear for you all. You would have studied in grade 11th. I think you would have not forgotten that. Because whenever you're studying a concept, right, students, when if the rule, or when I say Markovnikov rule or this one, if you don't remember, it's very difficult. I'll once again take it, just see. The addition means when I take, you have an unsymmetrical propene or an unsymmetrical alkene here. So when you have unsymmetrical alkene, what happens? The negative addendum means the rule states that whenever there is an unsymmetrical alkene like this, the negative addendum goes and adds to the carbon. Where does it go and add? The negative addendum adds to the carbon. Let's see, as I told you, the negative addendum goes and adds to the carbon having less number of hydrogens. So this is the negative addendum. It goes to the carbon having less number. Here 3 hydrogens, here 2 hydrogens, here 1 hydrogen. So what does it have? Break C H OH single bond CH2Cl. It is attached to carbon CH2Cl. Then what is the name of this compound? The name of this compound is ethylene chlorohydrin. This is ethylene chlorohydrin, right? So remember, addition of HOCl follows Markovnikov addition and the product formed is ethylene chlorohydrin. So this is the compound, isn't it? This is the compound. Right, students? Right. So hope whenever I say, or whenever you're learning rules, Markovnikov rule, Seytzev rule, anti-Markovnikov rule, you have to be very, very careful, because you should not forget the particular rule, because suddenly they may give you a compound and you should be able to know which one, whether it undergoes Markovnikov addition or anti-Markovnikov addition. Let's come back and do the next question. Now let's do the next question, students. Let's read this. So what did they give here? Basically, which of the following compound is an isomer of 1-butanol? So 1-butanol, they said they've given 4 options here. Which is the isomer of that? So basically, when I have to speak about isomer, what is an isomer? An isomer is a compound which has the same molecular formula, correct, but different arrangement in atoms. Means they have the same molecular formula, but arrangement will be different. So what should I compare? I have to compare with 1-butanol, right? So first of all, let us write 1-butanol. 1-butanol CH2 1. Okay, let us write but first. But is 4 carbon atom, all. This is CH3, CH2, CH2, CH2. 1-butanol is over. I have to compare. So what is the isomer of this? Right. So I said same number of, let me take the option A, 3-methyl 2-butanol, 3-methyl 1, 2, 4, okay, 3-methyl, okay. Next option, option C. Option D. Yeah, this is done. So 2-methyl 1-propanol. Okay, 2-methyl, right. Now let's see here how many carbon atoms are there. 1 2 3 4. I should have an isomer which has same number of carbon atoms total. Here if I see 1 2 3 4 5, here if I see 1 2 3 4 5, here if I see 1 2 3 4 5, here if I see 1 2 3 4. Perfect, isn't it? Right? So it should have the same number of same molecular formula but different arrangement. So here the option D is a correct answer. It is an isomer of butanol because it has the same number of carbon atom, but only thing is arrangement of the methyl group is different. Yes, right. This is how you're going to analyze the question. Let me see the next question, students. So here what do they give us? They've given us what is the which gas is emitted in fermentation. They asked me. So which gas is emitted in fermentation? Basically, what is fermentation reaction? So fermentation is nothing simple. Let us write the reaction. C6H12O6 glucose. Here in the presence of zymase enzyme. How does it do? What happens? The glucose in the presence of zymase enzyme, it gets fermented and it gets converted. Glucose gets converted into alcohol, isn't it? Right? So it gets converted to ethanol. During this process, carbon dioxide gas is evolved. This is the most important thing. If I have to balance 2 and 2, let's see, 2 2s are 4, 5 6 carbons, 5 2s are 10, 5 2s are 10. 11 12 hydrogens and 6 oxygens, right? So during fermentation in the presence of zymase enzyme, what is evolved, right? What is the gas evolved as carbon dioxide gas. So option B is the correct one. Let's come back into one more question. Welcome back, students. Hope you would have seen all the earlier videos. Keep practicing, students. I'm trying to do different varieties of questions. Almost as I told you, I'll be doing 100 plus questions for your NEET preparation. So one will be of different, every question will be of a different model, and I'm trying to make it in the easiest way, right? So in today's video, let's see what question are we going to solve. Here they've given at 27 degrees centigrade, 1 mole of an ideal gas is compressed isothermally and reversibly. Okay, an ideal gas is compressed isothermally, that is constant temperature, and reversibly done from a pressure of 2 atmospheres to 10 atmospheres. The values of delta E and Q are given. R value is given, log 5 is equal to 0.69. So I have to find the values of delta E and delta Q. 4 options are given. So basically they said a gas is compressed. So here the work done, let us see that work done. What is the formula? 2.303 nRT log P2 by P1. Here what is N value? Nothing is given, nothing about the gas, so 1. Ideal gas they said. R value is how much? 2. How much is temperature? 27 degrees. So 27 plus 273, it comes to 300 Kelvin. Pressure, how much is given? P2, how much is it given? They said 2 atmospheres to 10 atmospheres. So 10 is P2. What is P1? 2 atmospheres. So let us substitute everything. W is equal to 2.303 into 1 into R value is 2 into 300, T value log 10 by 2. When I solve this, log A by B, isn't it? So when I solve this whole thing, I get an answer of 965.84 calories. Now here they said at constant temperature, isothermally they said. So now at constant temperature, delta E value is 0, correct? So according to first law, delta E is equal to Q plus W. So Q is equal to minus W. Yes or no? Because this has become 0 at constant temperature, this value is 0, this whole value is 0. When this comes this side, Q is equal to minus W. So what is the value? Minus 965.84 calories. Correct? Yes. So the correct option for the given question Easiest way, isn't it? Just they've given us, we have to analyze the question and write it. So the correct option for this is A. Right. Let's come back and do one more question. Next question, students. Let's read this. IUPAC name of tertiary butyl alcohol. IUPAC means International Union of Pure and Applied Chemistry. According to that, what is the name of tertiary butyl alcohol? Right. First of all, when compound is given, let us draw the structure of this tertiary butyl alcohol. So tertiary means a carbon which doesn't have any hydrogens, isn't it? Means it will be attached to 4 different groups. So tertiary butyl. So carbon 1, 2, 3, 4. Okay, this is butyl and alcohol OH. So fill in the hydrogens. 3 plus 1 4, 3 plus 1 4, 3 plus 1 4. Now name it. Start numbering it. 1, 2. Correct? Yes. So second carbon. This is the third carbon. Now name. According to IUPAC name, it should be in numbers, isn't it? It is. So in the second carbon, you have methyl group. 2 methyl, 3 carbon atom. So propan. In the second position, you have all. 2 all. 2 methyl propan 2 all. So 2 methyl propan 2. Option D is the correct one. Correct? Yes. Let us do the next question. Let me turn my book. Yes. So yes. What is this question? A very big question. Let's read it and understand how to do the question. All right. So what do they give me? The best explanation for solubility of MNS, that is manganese sulfide in dilute HCl, is that. So best explanation for solubility of manganese sulfide in dilute HCl. So what they give me? They've given 4 options to us. So which will better explain the solubility of manganese sulfide in dilute HCl? They said here solubility product of MnCl2 is less than MnS. Concentration of Mn plus 2 is lowered by the formation of complex ions with chloride ions. Concentration of sulfide ions is lowered by oxidation of free sulfur. Concentration of sulfide or sulfide ions is lowered by formation of weak acid H2S. So basically, the concept of this particular whole thing, we can use this concept to distinguish between manganese, nickel and CO. Right? So in this case, what happens? Manganese sulfide in dilute HCl, let us read the reaction first. Manganese sulfide, when it combines to HCl, so I'll put it as H plus. What is this? Manganese sulfide is a buff colored solution, buff colored. But when it combines with HCl, this is going to break up and it forms Mn plus 2 plus H2S gases evolved. Okay, so here what happens? In this case, the concentration of the sulfide ions is lowered, isn't it, when it comes to the product? By the formation of what? By the formation of a weak acid H2S. So once again, here when I see the product, the concentration of sulfide is reduced by the formation of a weak acid H2S. Yes or no? So now what is the correct answer? After writing this, let us go back and analyze. Concentration of sulfide ores is lowered by the formation of a weak acid H2S. According to this, H2S is formed. This is a weak acid, and because of this, sulfide ore concentration is reduced. So the solubility, or the best explanation for solubility in MnS in HCl is D. Option D. Let's do the next question. Yeah, this is again a grade 11th question, which we have almost, one after the other, grade 11, grade 12, like that. We are trying to cover all the concepts of every chapter, right? Let's see this. What do they give me? C2 is rotated anti-clockwise 120 degrees. So they have given C1 is here, C2 is here, C3. It is rotated 120 degree about C2 and C3 bond. It is rotated 120 degree itself, both C2 and C3. The resulting conformer, what do we get? Okay, let us take that and rotate and see. Structure is here. CH3, H. This is hydrogen. This is hydrogen. CH3. This is H. Now we have rotated to which one? 120. So that is anti-clockwise direction. Anti-clockwise, because they have given here anti-clockwise. So I have to rotate 120 degrees anti-clockwise. Then when I am rotating like this, just here, like this I have to rotate. So CH3 comes here, isn't it? This goes here. Hydrogen, 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 and CH3 is here. So what is this conformer? This is Gaussian conformer. I've also done a video for conformations or conformers of propane, butane, all those things. Please watch the video. You will understand what actually are the conformers, right? Because conformation is very important in hydrocarbons chapter of grade 11th. So here the correct option is Gaussian. Right, now let's come back and do one more question. Let me turn the page. Yes. Chili saltpeter is an ore of, very easiest question. So basically sodium nitrate NaNO3 is known as chili saltpeter or Peru salt. What is this? Basically NaNO3 is known as chili saltpeter, or it is called Peru salt. So the correct option is sodium. So chili saltpeter is nothing but sodium nitrate, no? So the ore of sodium, right? Welcome back, students. Hope you would have seen the earlier videos. Now let's come back and start, because I'm doing gradually all the questions one after the other, solved with clear explanation. Do watch all the videos, students. Let us read this question. Which of the following will have least hindered rotation about carbon-carbon double bond? So basically least hindered means which will have less strain, and which will whichever has smaller atoms will have less strain. That is understood, isn't it? Let us first write that compound having smaller atoms will have less strain or steric hindrance. Now this happens only when free rotation around carbon-carbon easily takes place only in alkenes. That is the second point. Remember this, because more bulkier groups in alkenes or alkynes, double bond, triple bond, more bulkier groups are added means automatically the steric hindrance increases. So free rotation around carbon-carbon bond takes place in alkenes. So let's see which is alkane here. Acetylene, this is alkyne. Hexachloroethane. So hexachloroethane has bulkier group, means chlorine group, which hinders rotation here. Though it is an alkane, but chlorine group hinders rotation. Next comes ethane. It is an alkane. Ethylene, alkene. So I told you free rotation around carbon-carbon bond takes place only in alkenes. So the correct option is ethane, isn't it? Right. So let us come back and see next question, students. So here, right. Okay, this is the same question repeated. Let's see this. The angle between the overlapping of s orbital and 1p orbital. I think it's the simplest question they've given. The angle between the overlapping of s orbital and 1p orbital is. So they said 1s. Let us see that. 1s, which is spherical, is combining with one more p, which is dumbbell in shape. So 1s and 1p, what is this axis? This is along the axis. Linear, isn't it? So the shape is linear. So here the angle is 180 degrees. So the type of overlap between 1s and 1p is nothing but 180 degree. The correct option is this. So let me take you to the next question. Here acetic acid and HCOOCH3. Okay. So here basically most of the students, they get confused when naming the compound. HCOOCH3, CH3COOH. What is the name? How should you remember this? Basically in one of the video I did this question also, how to name, because most of the students, they get confused and they don't know how to name it, because the common thing means the concept of that they have forgotten. Nothing. Simple, remember HCOOH is what? HCOH is nothing but formic acid. Now what do? We have taken out H and we have written HCOCH3. This is nothing but methyl formate. So methyl formate. What do they ask? Both of them, acetic acid and COH, the reverse order, isn't it, are what? Are they functional group isomers or tautomers or position isomers or not an isomer? So basically these two are here. See here, this is acid group. This is also CO group. So these two functional group are the same, isn't it? So what are functional isomers? Basically functional isomers are structural isomers which have same molecular formula. So let us write that first. Functional group isomers are structural isomers which have same molecular formula, right? So structural isomers which have same molecular formula, that is what we have written. But important thing is, along with this, the functional isomers, they should have same number of atoms of same elements. They should have same number. See here, 2 carbons, here also 2 carbons, hydrogen 1, hydrogen 1, here hydrogen 3, hydrogen 3, 2 oxygens, 2 oxygens. Means for the functional group isomers, what should you remember? They should have same number of atoms of same elements. Remember the next important thing. Functional isomers, if I am writing, should have same elements, should have same number of atoms of same element, but atoms are connected in different ways. Here like this. So remember that, students. So here the correct option is functional group isomers. So these are the conditions which you should remember for functional group isomers. These two remember so that you can easily do that, right? So next question. Here basically a thermodynamic question is given. It's a direct question, if I have to say, nothing to derive. So for polytropic process, PV is per N, that is constant. So Cm, molar heat capacity of an ideal gas, is given by. So basically it's a direct question, it's a direct formula, I have to say. So for they've given Cm of the ideal gas is given by. So this is the correct formula. I'm directly taking it because nothing derive. Remember the formula directly, right? Now let's come back and do one more question. What do they give me here? Carbolic acid is what? So carbolic acid is an older name of phenol. Remember that. So what is carbolic acid? Basically, carbolic acid is an older name of phenol, or what is the other name of phenol? It is also called as hydroxybenzene or phenyl hydroxybenzene. I think this is enough for you. So correct option, carbolic acid is phenol. This is the correct option, right? Let's come back and do next question. The density of glycerol is higher than propanol. They've given this question. The density is higher than propanol. So whenever a density question is given to you, remember, you have or the easiest way to approach the question is in terms of hydrogen bonding. Remember, once again I'm saying, whenever a density question is given to you, density related to hydrogen bonding, that's the easiest way. So they've given glycerol. Why is the density of glycerol higher than propanol? So what is glycerol structure? Basically, glycerol is CH2OH, CH2OH, OH and H. This is glycerol. What is the other one? Propanol. Propanol, OH. 1 carbon, 2 carbon, 3 carbons. Prop. Now see here, I said whenever density concept is given to you, speak in terms of hydrogen bonding. How many OH groups are here? 3. So how many, if 3 OH groups are present, 3 OH groups, it can form hydrogen bonding from 3 sides. So what is here? In glycerol, extensive hydrogen bonding is there because of, due to 3 OH groups. But in case of propanol, how many? Only 1 OH group is present. So due to extensive hydrogen bonding in propanol, the density, extensive hydrogen bonding of glycerol, the density of glycerol is high. Density of glycerol is high. So which one? The correct option is hydrogen bonding in the second question, students. So remember, whenever density question is given to you, you can make this hydrogen bonding as an answer. Let's read this question. Which of the following will not show mutarotation? Okay, so here mutarotation concept, here also I did one video of mutarotation. Please watch that. Right, so which of the following will not show? Basically, if I have to speak, glucose shows mutarotation, lactose shows mutarotation, maltose also shows mutarotation. So directly remember, I'll give you the reason also. So maltose, glucose and lactose, they show mutarotation, but only option is sucrose will not show mutarotation. What is the reason? Let us first write what actually is sucrose made up of. Sucrose is basically made up of a combination of a glycosidic linkage between alpha glucose and beta fructose. Okay, sucrose is, means it's a combination. It's made up of alpha glucose units forming a glycosidic linkage with beta fructose. Here, let us draw the structure. What is alpha glucose? Hydrogen, CH2OH, hydrogen, H, OH, OH, H, H, OH. This is hydrogen, which is forming a glycosidic linkage with, now this is what? Alpha glucose. Now I am drawing beta fructose. Okay, I should draw like this. You have CH2OH here, CH2OH, OH, H, HOH. Okay, now this is the glycosidic linkage formed between alpha glucose and beta fructose. Here, important thing is the glycosidic linkage, whatever is formed between anomeric carbon, means anomeric carbon is what? It is C1 carbon. So when do we call anomeric carbon? Anomeric carbon is something, or that C1 carbon, before it reacts with the carbon, means the carbon internally. When we draw the cyclic structure, before that reacts, when we draw a straight chain like this, isn't it? We will have in this form, isn't it? CHO. First one, before it reacts with the cyclic, or it reacts with the fifth carbon in glucose. So that is anomeric carbon. C1 carbon is the first carbon, which is called, means you call that before it reacts with, or it forms a cyclic structure within internally. So here the anomeric carbon of glucose and anomeric carbon of fructose, right, does not exhibit, because the glycosidic linkage between anomeric carbon of glucose and anomeric carbon of fructose is fixed. So because the anomeric carbon, because of this anomeric carbon, it does not show metarotation. Once again I am repeating, sucrose does not exhibit metarotation because the glycosidic bond which is formed between C1 of glucose and C1 of fructose, anomeric carbon of fructose, does not rotate. So hence, what happens in sucrose also, hemiacetal formation is not shown. This is the main reason, hemiacetal. But you can see hemiacetal formation in maltose, glucose and lactose. Right, students? Yeah. So let me come back and do the next question. Now let's come back and do the next question. Let's see. Now basically this is a chemical kinetics chapter of grade 12. Right, let's see this. What do they give us? The rate of a gaseous reaction is given by the expression R is equal to K into concentration of A reactant, that is concentration of B reactant. Done. If the volume of the vessel is suddenly reduced to 1/4 of its initial volume. Okay, so the volume of the vessel is reduced to 1/4 itself. Done. New rate relating to original rate will be what? Simple basically. So first of all, they have given me this expression, R is equal to K into A into concentration of. Done. We very well know concentration means what? Nothing but K into number of moles of A by VA, correct? And which is again equal to NB by VB, correct? Why did I write this? Since concentration is equal to N by V, right? That. Let's come back. Now this is R. Now they said if the volume of the vessel is suddenly reduced to 1/4. Now let me make that rate expression as R dash. This is R and this is R dash. This becomes K, A and B. Now the volume only is changed, isn't it? Concentration is the same. So this becomes K Na by V dash A dot NB by V dash B. What did they say? The volume means if the volume of the vessel is suddenly reduced 1/4. So by 4, this is by 4. And now let's further solve this question. This becomes equal to 4 for 16, isn't it? So this, I'm taking the 16 this side. So this becomes R dash is equal to 16K Na by V dash A into NB by V dash B. What is this whole quantity? Basically, this is nothing but, means if I have to take R dash, we have got it from that expression, that is R. Means initially this concentration is nothing but equal to this R value. So R dash is equal to 16 times R, isn't it? So the answer is 16 times. Hope this is clear, students. I have taken that, and R is equal to R dash. So R dash is equal to the concentration K into A. So but K into A into B is what? R. So I have taken that directly. Right. Let's come back and do the next question. After chemical kinetics numerical, there's one more numerical. This is, I think, from the solution chapter. Let's do this question and solve it. So what do they give us? Suppose 5 grams of acetic acid are dissolved in 1 liter of ethanol. Okay, so 5 grams of acetic acid itself, it is dissolved in 1 liter, that is 1000 ml. Then assume no reaction in between them. Calculate molality of resulting solution if density of ethanol is given so much. Done. So let us write the data, what is there, and let's calculate. I have to calculate molality. Right. So molality is nothing but moles of the solute by weight of the solvent in kg. Yes. Now let us write the data what we have. First thing is weight of acetic acid CH3COOH dissolved. How much it is acetic acid dissolved? Acetic acid dissolved is how much? 5 grams. Right. Done. After that, volume of ethanol. So volume of ethanol. How much is volume of ethanol? It is nothing but 1 liter. How much is 1 liter equal to? Nothing but 1000 ml. That's over. Now this is volume of ethanol. Now I have to find weight of ethanol, because solvent weight I need. How much is this one? Basically they said density is given. So therefore weight of ethanol, actually density is equal to mass by volume, isn't it? So weight I have to find out. So I'm taking that out and multiplying with 1, because volume is 1000, density is 0.789. This comes to 789 grams. Weight is over. Now substitute molality of the solution is equal to, what is molality formula? It is nothing but moles of solute by weight of solvent in kg, moles of solute by weight of solvent in kg. This is the thing. Now I have got what number of moles means the way, this in weight is given to me, that is 5 grams, and now weight of the solvent also. So I can know, I'll take that directly. So moles is what? Weight by molecular weight, isn't it? So molality is equal to weight by molecular weight. How much is the weight? 5 grams. Ethanol molecular weight is 60 into 789 weight of solvent kg divided by 1000. So finally when I solve this, I get an answer of 01056. So the correct option is option C. Hope this is clear, students. What did I do? I have just taken that density, and then I have used the formula of modality, and that molality, that is number of moles of the solute by weight of the solvent. So to get the number of moles of the solute, what did I do? I have taken weight by molecular weight. So weight of solvent, we have already got this from this statement, isn't it? From the density. So finally I've got the answer. So nothing, it's easy. So the correct option is option how much you take it? 1056. No, this is not C option, students. Sorry, 1056 is this option A. I'm sorry for that. Let's come back and do the next one. Now, in the next question, again we have got one more numerical. Let's read this. The pH of 1 molar ammonia aqueous solution. The pH, I need to find the pH of 0.1 molar ammonia aqueous solution. Kb value is given to me. Right, so let's start off. First of all, how to solve this question? Let us note what data. Kb is given to me 1.8 into 10 raised to the -5. Done. What is the concentration of ammonia? Concentration of ammonia given is 0.1 molar. Now let us write the reaction. What did they say? Aqueous solution. So that means ammonia is dissolved in water, which dissociates into ions, ammonium plus ions plus OH minus ions. Right. Now what are we going to take? We have to find the pH value, isn't it? Now what do we do? Let concentration of NH4 plus. What am I taking? Just see, concentration of NH4 plus should be equal to concentration of NO. OH minus, OH minus, it is X. Now, what is Kb formula now? Concentration of the products by the reactants. That is nothing but NH4 plus OH minus divided by NH3. Now what do we take these two values equal to? X. So make it X into X. What is the concentration of ammonia? 0.1. Correct. Now what is Kb value? It is nothing but 1.8 into 10 raised to the -5, and X into X is X squared by 0.1. Correct. Now I take out this cross multiply the X, you take this here, cross multiply, X square becomes equal to 1.8 into 10 raised to the -6. Hope this is clear, students. Now still the sum is not complete. Let's see. Now minus log X square, because I'm applying log on both the sides, here also and here also, this becomes minus log 1.8 into 10 raised to the -6. Right? Well, now to find this value, 2POH minus, because we have taken OH as this, X is equal to minus log 1.8 into 10 raised to the -6. Correct? Now POH is equal to 6 minus log, because this is there, isn't it? 10 raised to the 6. I'm getting it down. 6 minus log 1.8 divided by 2. Hope students this is clear. Hope I'm not confusing you all. Right, it's a simple thing. It is basically your log value which we have taken in this way. Right, now let's solve this further. 2 3s are 6 now, so this becomes equal to 3 minus log 1.8. Okay, done. So we very well know pH is equal to 14 minus POH. Now pH is equal to 14 minus POH value is this, isn't it? So 3 minus log 1.8 is 0.127. So pH is equal to minus of minus, isn't it? So this is 11 and this is 1 point minus 0.127. So when I subtract this, minus into minus plus, okay, so I get an answer of pH almost 11.13. let me see once. This is minus into minus plus, yeah, right. So I think, you know, this here I've written wrong, isn't it? 14 minus 3 is 11, minus into minus is plus, so together it comes to 11 point almost 12713. So this is the answer. So the correct option is 11.3. Hope this is clear, students. Now let's come back and do the next question. Right, let's see what is the next question given to us. Numerical, after numerical done. So here they've given us this is a coordination chemistry chapter. Let's do this. They've given the hypothetical complex triamine diaqua chlorido cobalt 3 chloride can be written as. So they've given the complex here, name of the or the nomenclature of the complex we have to see. So here triamine diaqua chlorido. Let's see what is this. Triamine, okay, everywhere this is amine. Then they said diaqua. Here this is diaqua, this is diaqua. Chlorido, okay, chlorido, done. Cobalt 3, chlorido, cobalt 3, okay. In this complex, when I see, this is chlorido, isn't it? Well, the ion, yeah, but here everywhere chlorine is there, but important thing is the charge on this. Here they've given cobalt 3 chloride. That's why this is an hypothetical complex basically. So this, according to this name, this is an hypothetical complex, and the correct option for this is A. Done? Yes. Now let's come back and do the next question. So what is this given? Ozone in stratosphere, okay, is depleted by, we very well know ozone layer in stratosphere is depleted by chlorofluorocarbons, isn't it? Yes, yeah. So this chlorofluorocarbons are causing ozone holes.